this is really appropriate for kind of chalk fly-throughs or anything where a scene is just not moving at all. This is a very simple animation that we created for in a few days, where we kind of had a static scene, nothing was moving, and we were simply flying through the space in a kind of nice chalk way, and then some of the static images were kind of popping up to explain the space and connect the images together. It was really just an image set which they wanted to kind of try and communicate where these images were sitting within the building. So locating each of the images, and the kind of fly-through was a vessel to do that. So these are really simple scenes to set up. Chalk fly-through, and often we don't actually render every frame for these things. We render every other frame, and we use frame blending to kind of cheat. So when we're in kind of tight deadlines, we can only render half of what we need. But setting up these kind of scenes are very easy, and we'll try and show that again. And then again, even on the creative side of things, with a film like Megalomania, if we kind of skip through to some of this, a lot of this was apart from certain elements, a lot of this was kind of just rendered in fly-through, and with very simple scene setups, and render times were very low. Some elements were moving objects later on in the film, but most of the film was very static, moving through simple scenes with nothing moving. So in both accounts, we need to set up our scene. So basically, what we need to do here is we want to generate our light cache and a radiance map. Now, there are different ways that people are showing you how to do this on the internet, all of which are slightly different, whereas the method we use is to bake it in one pass. Certain techniques use a kind of light cache technique first, and you do it separately. However, there's no real need to do that. You don't really need to kind of set up your light cache, and render it on fly-through as a separate pass. You can do it all in one. So traditionally, you would set up your system like this. You would have light cache set. You would have fly-through set in the mode, and that's the same as setting use camera path. So you don't need to have both settings selected in this way. And then ideally, you want your scale of your light cache to be on world. And when you do this, you really need to up the subdivision size of your samples here to something more like 2,500. And what this is essentially is world setting will calculate the kind of 3D scene, and the whole scene is one light cache file, where a screen will just do what you see within the screen. Now, this isn't advisable to use when you've got a huge scene, where there's lots of different objects and a large scene around your camera. But in this scene, for example, it's what we see in our camera is more or less what we see in what we have in our model. So if this was a small part of a much, much larger model, then we wouldn't really want to use world, because we're not going to get enough subdivision around our space to kind of generate a good light cache. So, but on this scene, it's appropriate to use world. All interior scenes, you should be using world. However, on exterior scenes, large exterior scenes, screen can be fine. So on screen, light cache of 1,000 is normally good enough for animations, and on world, a light cache of 2,500 is normally quite appropriate. Again, you want to check the number of the cores in your machines or your render farm, and just make sure that you're generating the passes, the number of passes within your light cache reflects that, because otherwise you've got power in your computer that you're not using. If you use the default 8, and then you've actually got 12 cores within your machine. Once we've generated that light cache map, we'll render that out, and this is different to the previous method, because we can send this to the farm to all of our nodes. So it's not dependent on adding detail to a single map. Each of these maps are independent from each other, so they can be made on the they can be generated on the entire farm that we've got to speed the process up. So if we have a look at these files, for example, we have our pre-pass file already calculated. We have our light cache. We have our pre-pass dummy file that is generated when we press save on those maps, and then we have the rendering of all of the files here. So you see minus, it displays it in a funny way, but V-Ray reads it correctly. So this is like 00, 001, and then it's got minus 001, 002, minus 002. It doesn't matter what order that's displayed in, that's just a naming thing for Windows, but V-Ray will read this properly. It will read it as -2, -1, 0, 1, 2, 3, 4, 5, etc. Look at the JPEGs that we're going to use. I'm not going to go through how we made the HDRI, but I'm going to kind of introduce you to a few bits of kit that we used to capture them, and just understanding what's the best tools really. So let's just quickly find our files here. So like we kind of briefly explained, this is our HDRI, and it's made up of 7 different exposures at 45-degree angles, taken on a kind of fixed tripod, which you can kind of see just here. What you can also kind of see here is our Nodal Ninja, which is our kind of device that we're using to rotate our camera on a fixed angle brackets. So we're rotating that every 45 degrees, and we're taking 7 different exposures. And we're not doing that manually, we're doing that using a promote control. Is a kind of like device which connects our camera, and we can kind of really easily do time lapses and exposure bracket, multi-exposure photos and things like that. And then we're doing all of that with a 5D with a non-crop sensor. Again, if you did this on a cheaper camera or even a 7D, you wouldn't get a completely spherical image, you'd get a cropped image basically, which is important when rebuilding the kind of 360 degree thing. But you can see from our HDRI that we're getting a great amount of lighting data. So you can bring it right back, and we can see that the sky is our light source, and it's giving us the kind of detail that we need for our lighting. And because we're kind of always within the streets, we're not going above it. We can just use this HDRI. We don't need to use any of the light whatsoever. You can see in the file that there was a directional light, and we did play with that for a little while, trying to recreate the lighting as accurately as possible. But we found that once we actually played around with the V-Ray light, with the kind of settings of that HDRI, we could get it roughly working. What we sometimes do is kind of activate V-Ray RT with nothing in the model, and just get our dome light source in the right place. And I actually did a kind of test for NVIDIA's new Maximus system last year, and testing specifically RT in production, and found it actually very useful for lighting setups and material setups for scenes. And I wrote a big case study on the NVIDIA website, which you can kind of hear more details on that if you're interested in kind of learning a bit more about RT and its relevance within ArcViz production. So like I was trying to say, render your entire scene fixed, and then go in and on activating your DMC again, and you can actually start testing what things are doing. Especially if you're kind of using motion blur, you want to go in and actually test a few frames first. This file has a habit of, because it's such a large file, it has a habit of not liking to be moved in the timeline unless you're just rendering. But we'll try and move to a frame without the file crashing. I like to make things difficult for myself in live presentations by doing really complicated scene setups. The reason why this is taking time is because this is a very large V-Ray, animated V-Ray proxy. And we find that we actually use XMesher more these days. XMesher is a really great kind of meshing system for animated objects. I think for static objects we still use proxies mainly, but for animated objects we use XMesh more, and because it gives us a much better preview in our viewport of our geometry than proxies do, and they tend to be a lot more reliable. Okay, so if we change this to say frame 100 instead. But while that's kind of loading, let's go back into our base geometry file and talk again about this material that we have on all of our base geometry, which is our V-Ray material wrapper. And again, this is the same thing. We have our V-Ray material within the base of that material wrapper. We have our camera map per pixel with our texture linked to our camera, and that's projecting our footage onto our geometry from the camera. And we can mask this. We can do all sorts of different options we have within the camera map per pixel that we don't get elsewhere. And in our material wrapper, this allows us to create our alpha contribution for this anything that this material touches as -1, so that our geometry that's within our space here, if we go back into our camera here, the geometry that we're putting within here will render, because that by default, obviously all the geometry you put in has an alpha contribution of 1. But then we're telling this geometry with this material on to have an alpha contribution of -1. But we're affecting the shadows. So what that's going to do is it's going to give us the object that we're rendering that we're rendering normally. The kind of contact shadows of that are going to bleed onto our base geometry here. Now, there's two slightly different workflows that we used while doing Jonah regarding the use of the use of direct shadows onto the base geometry, which I'll talk about more when we start comping things. And it kind of is more about how this affects the alpha work. So we're telling the geometry to receive shadows from our other objects, but then we're also saying, is that going to be affected in the alpha? So by checking it, we're saying that the geometry in here is going to be kind of like completely clean cut, and by unchecking it, we're saying that the alpha of that contact shadows and of our geometry that we're rendering in is going to kind of bleed on through the alpha. It kind of makes more sense when you talk about this in composite, when you can actually see an example. But you'll get used to what this is in a second. Let's just look at this. What we'll do is we'll look at our RGB. So we'll put our RGB over here. So that's our raw render, that's our RGB. Now, more often than not, you don't actually use this guy in Nuke, which is quite interesting. You kind of rebuild him using the other passes. And there's some passes that are that you render out for rebuilding, and there's some passes you render out just for effect or color grading or masks. So let's just go in and isolate our masks. So we have our alpha, and with this file, we haven't got our sky separated out. We're rendering that out now, but I'll show you the differences between those two things in two different files. Let's just move our kind of passes we'll use for editing there. So basically, there's a few passes you need to rebuild your RGB. You need global illumination, so we'll put him over there. You need your V-ray reflection, your V-ray refraction, self-illumination if you've got self-illuminated objects, so it's just being aware of what you've got in your scene, specular, lighting, and background if you have a separate background in your scene that isn't part of your lighting setup. Okay, so at the moment, if we go back into our kind of viewer mode, at the moment these are very separate passes. You know, we can see our global illumination separately, our reflection, refraction, our self-illumination. We've got our dome visible, so we have that rendered in as well as our kind of little light here. We've got our specular, but we don't have any specularity. So it wouldn't in this particular scene, it wouldn't actually be a problem if we didn't include this, but it's good practice to include the ones that you need anyway. And then our V-ray lighting, right? So the way that we merge these together is using the merge node. So yeah, Nuke is pretty logical. And then if you double click this node, you won't be able to see anything because you're in you're just in your node graph here. But if you double click him, you'll get options within the properties, and that's where you can kind of change the parameters of what this object's doing. Likewise, if you double click on any of your nodes, it will kind of bring up options for that, where it's saved, the frame range, you can alter that, and all sorts of other options that you have here. So if we could double click on our merge node again, if we had this on the default 10, what would happen is this would quickly fill up, and it would get a bit confusing, and we'd have to kind of scroll down and all sorts of things. So I'll keep this on 1, just for organization's sake, and just double click on the node that I want to see the options for. So the default merge setting is merge over. What you want to do is change that to merge plus. And these are often called your plus files, or your plus passes. That's what it's often referred to in visual effects. So the way that you kind of use Nuke is that everything works with the kind of B channel pointing up and the A channel pointing us to the side. Now here we haven't really got a background. That's not really got anything there. But just as a work of practice, I always put my background on the top here, and then I kind of plus in all of my other read nodes on the side. So what I'll do is now we've set him to plus, I'll copy him and paste him down, and I'll just keep attaching this chain, and then I'll just see what that's doing. So here I've added my global illumination and my reflection. So these are separate now. These are separate passes. So now if I copy that and paste them again, B and A, I've now added my refraction. Copy again, self-illumination. I've now added my self-illumination. So let's just go down and build the other two passes here. There's nothing on the specularity, but we'll leave it in there anyway, just in case we want to re-render, and then we do change those materials. So when we go to the bottom there, we press 1 on our viewer. So here's our viewer. So we have our rebuilt RGB and our RGB, and let's just check that they're the same. So we press 1 on that, 2 on that, and they're the same, right? So now we've successfully rebuilt RGB with all of these different passes, and it should be obvious why we do this, because now we have an immense amount of control over everything to do with our render. So there's lots of different things we can do here, right? So the first thing we want to take note is a few more settings within the merge node. When you create complicated compositions, you might be using footages of different sizes, rescaling things, like you use different nodes called reformat to kind of change the size of different things. You might be comping in a different background, which is a different size. So the kind of bounding box for all of this data can get quite large. So you want to set the bounding box to B, which always then reads through your B channel and will read whatever is at the top of your setting here, which is in this case, your 1920 footage. And this becomes a bit more important later on, but it's just an important thing to kind of get used to doing early, is setting your bounding box to your main format. Because otherwise it's going to create a union by default of all of your elements together. In this case, all of these are the same size, so it makes no difference. But I'm just saying, watch out for that, because it can really change the speed of your scene when working with really heavy files, and just be aware of what it does. We have lots of different options here within our merge node. We can mask it, so we can kind of say, okay, actually we don't want the reflection on these balls here. We're gonna mask it there, or we're gonna mask any of the kind of elements using manual roto, or we can kind of mask using any of the kind of channels that we export. There's a mix amount. So if you double click on our reflection, we can kind of change the mix of that. So we can kind of alter how that's working on the whole scene. Now, there's a temptation to just alter the mix amount of everything, but there's a slightly more dynamic way of controlling the intensity and the amount of your passes in between the merge node and your read node. So if we just click on the tab and we go to multiply math, and what this is, if we plonk him in there, and what we have there, if we just kind of copy that node again, if you just drag a node onto a line, it will automatically give you the option to kind of insert that into anywhere, right? So if we double click on our multiply, on our global illumination, for example, what we've now got is a value parameter of 1, but we can go minus or plus, which is a hugely powerful thing to be able to do. We can kind of take away global illumination from our scene. and we can add global illumination to our scene, right? So by default, I tend to kind of have these within all of my read nodes here, just to give me the flexibility of being able to tweak each one. But so this is basically how we set up our scenes. We have all of our clones, which we can then use. So we'll rebuild our RGB back here. It's called, we won't worry about the naming. If we had more time, we would change all of these to the name what we want. We know this is the RGB color, so we can plonk him on the side here. We know this is the background. What I tend to do also is just make sure that I'm using the right ones. This is our radio ray lighting, specular, self-illumination, our refraction, and our reflection. So we had these in slightly different orders before, but that doesn't really matter, we haven't changed much. And again, we can just easily deactivate a whole bunch of stuff there. If you press X on a node like this, it will deactivate the whole thing, which is sometimes very useful. So also when you've highlighted all of your elements, you can see exactly where everything's linking to. That becomes really good because when you want to bring in a new set of new renders, for example, you can kind of bring in your new set. Let's just, for the sake of argument, say that this is your new set that you brought in, you've updated things. You can just select everything in your scene and then very quickly just update your scene with the latest assets. What we tend to do, which I'll explain more later on, especially for our kind of ArcViz image workflow, is that when we're in the development of a project, we kind of have a working folder, a current folder, and then we save all of our latest renders into that, and we overwrite. But then we copy that current folder and we date it when we do that. So we've always got a record of our kind of what we've done, but then we can have a current folder which is always linked in our Nuke comp, and then which is automatically updating every time we re-render, and then we have a comp which is automatically updating with all of our passes and things like that. And we'll go through that example slightly later on. So this is kind of our basic kind of setup for rebuilding our RGB. Now, I want to talk about how we use the passes and masks and the shuffling out the different channels. So we've got our RGB export here. Let's just work with that for now. Or actually, let's update where we were at before, because we changed our background slightly, which we were slightly more happy with. So let's export where we're at there. Again, render him out. So this guy, we do the same thing with this guy. We would put him with our read nodes. We might want to organize this and name things slightly differently in different background nodes. We've got our export here, got our postage stamp, and then we are, if that's going to update, hold on 1 second. Let's have a look what we've got here. Delete him, do a new postage stamp. Not too sure why he didn't want to do that. Okay, what we've done, if you just go to there, export that again. Let's just have a look at updating this guy, reload. There we go. We needed to reload him because we'd automatically overwrit and we didn't update the read node. So this postage stamp, again, we want all of our kind of anything we're reading into the file to be up the top, and then we create our new postage stamp, hide the input, and then here's our new exported guy here. So let's continue with this tree down and let's look at some color correction. Go in full screen mode while we're working, or we don't need to see the viewer. Let's start using some of these. Again, these are clones of our read nodes. We don't want to use these. We want to use our postage stamps. So let's take our two color correction guys here. Copy him, which is fine. You can clone that, which is, it works, but it's just not good practice, basically. You can clone from a postage stamp, but we tend not to try and do that. So let's increase our tree here. Let's click on our postage stamp. Let's click on our grade node. Let's bring this in here. And then we'll attach automatically, all the time these arrows are on the side of nodes, on the right-hand side, are always masks. So that arrow will always be a mask, no matter what node you're looking at. And you can mask almost every node with whatever you want. If we look at this now, we can see that we've got a grade node. Let's double click him. We'll notice that our mask is selected, but it's got RGB alpha on, and we want to select the red channel because that's the selection we want to change here. And then now we can alter this path separately, which is in this case our glass. And that's as simple as it gets with kind of changing the kind of colors using the multi-matte IDs, and these only work with the multi-matte IDs. We never use wire colors or anything like that within Nuke. It's not kind of like a bodged job in Photoshop. You have to get your IDs working properly and make sure you're rendering out lots of different multi-matte IDs for the ones you need. Because Nuke works with the RGB. There are ways that we can kind of key light certain colors and manually make a mask, but this is kind of the best way to do it. This is with selecting the mask here. So again, let's do that with another element here. Let's select our green for this one. Let's change the color of this, or the intensity of this element. You can see here, and what we'll do is we'll tend to kind of organize our structure, so we're kind of like calling this, if we put another backdrop here, and we'll call this, adjustments or whatever, same as you would do with Photoshop. Say again, sorry? See how the mask looks? There's a question in the... Okay, if we... there's a question to kind of see how the mask looks, like what the... in a kind of like alpha or kind of like visually what it looks like from the audience here. And there is. You wouldn't really need to for stuff like this, but you can.
It's more multiple colors and multi-matte, just to be quick testing without using the correction.
Let's just see, because I'll be going through slightly later on, shuffling out channels and creating alpha channels and things like that. But let's just see if we can kind of illustrate this, obviously, in this instance. Again, because you can see literally what this is here, you wouldn't really need to go to see it in an alpha, because you're not really creating an alpha here. You can use alphas as the mask. You can kind of manually create, rather than choosing a red, blue, or green, you can choose RGB alpha, and then that'll pick up a black and white image that you pump in here, which is set as an alpha. So let's do an example of that now quickly while it's being talked about. If we click on this and press shuffle, we're creating quite a lot of motion blur at this point. And although we did bake in some motion blur, we kind of try and do half and half to give ourselves a little bit of flexibility. On some shots, we kind of render, when we have to bake in the motion blur on shots like this, we want to kind of give ourselves enough of a head start that it's kind of aiding our real smart motion blur, but then we don't want to do it too much, so we can't take some of that back or add some of that in post, basically. And you can kind of mess around with, we've kind of done lots of different tests with the kind of velocity pass that you can export within V-Ray, and we've had limited success, to be honest with that. There's lots of ways you can do that within Nuke. You can even use the kind of source here for, you can plug in the velocity pass here. So the real smart motion blur does support the velocity pass, but again, we find, if for this particular shot, we found it much better to kind of bake in part and then just add our kind of pixel motion here. But I'm just going to turn this down a little bit. It looks a little bit too extreme. Again, what you want to do is you want to match this to your footage. So I think at this stage, we definitely want to bring in our footage, especially if we want to start kind of grading this in. So we'll bring in our simple JPEG sequence. We'll have a look at what that looks like here. So all we've done here is given it a slight, no, we haven't actually graded this. We'll just put these in place for grading. So we kind of leave these grade, color correct, and color lookup nodes there. So they're ready for grading in the kind of standard setup we have. So if we now click our merge over node, which is what we have. So what we've got here is that we've kind of piped in our feed through our depth of field and our motion blur, and then we're kind of piping it into our main tree here. The reason why we've kind of extended this out to the side is because when our comps get large, and we want to be able to turn off the motion blur and turn off the depth of field all in one, when these are all lined up, what you can quite simply do is select them all on the side and press D, and then you've deactivated all your kind of like heavy layers, which are going to slow down your viewport. So that's just why we have this going to the side here. We could just have this pumping down here and then feeding back in. It's just graphically we have it on the side so that we can turn it off very easily. We're going to ignore this light wrap feature for a second. We're going to talk about that more on another scene. And then what this line is doing, it's kind of going into our merge over node, right? Ignoring everything else apart from our merge over node for now. And this is saying that this layer is at the bottom, our footage is at the bottom, and our render layer is kind of merged on top of that. So anything that's above anything else is like a layer system going down. So let's have a look at that. The matte shadow is something we're going to talk about on the next shot, because what we've done here is that we've baked in our alpha, right? So our alpha, if you remember when we were talking about the matte shadow material, our alpha is baked in. So in that material for this context, we've unchecked the effect alpha channel. So that we've checked rather the effect alpha channel, so that our contact shadows and our kind of light that this object is creating is actually affecting directly our alpha, not just the matte shadow material. So in this method, it's good and bad. It's good because we can kind of bake in our alpha, and the contact shadows will work, work fine. If we take off our render completely, if we unplug this, so let's just put a little dot here so I can go back. If we unplug our render, you can see that there's no shadow there. If we plug it back in, the shadow's there, and we can kind of play around with the alpha and blur this slightly to get this better. But that was probably also if we created a slightly more accurate model, and then we get slightly better shadows. But again, with the motion blur activated, that doesn't matter too much, because as soon as we add motion blur to this, you're going to see that kind of smooth out anyway. So we weren't too bothered about that. But that's essentially, our shadows are baked in to our render pass here, right? So we'll talk about how we use this how we use the matte shadow material on the next shot. In this shot, we kind of baked it in, and again, at this point we were trying out different workflows. So we were kind of like on each shot. This was our first project learning Nuke. This is why we're kind of showing a few different shots where we kind of figured out a few different things, basically. So it's good to kind of go through. And you can see already how from this initial comp, which the base principles are all there, all these different elements are there. It's just that we got used to organizing things in a slightly more graphical way, which then more people can kind of come into and understand, basically. So that we develop this kind of template so that people can kind of come in directly and know what's going on, just labeling everything, basically. So we'll talk about the matte shadow in the next scene, and we'll leave the ambient occlusion because we haven't got it, we didn't render one out for this one, or we're not going to use it. So essentially, just to kind of simplify this composition, let's just bring this guy. Let's delete these two because we don't actually need them to simplify it. And again, this looks a little bit complicated, but this is developed because we want to essentially create our roto masks. So we can talk about that a little bit. So our roto masks are essentially rotoscoping nodes. So if we click on one of these, we can see that we've got a line here, which is kind of surrounding our main character. And we've got one of these for lots of different elements, like the gaps in there. We've got one for the bike. And again, this roto node was actually created by a junior person that we kind of employed from Escape Studios in London, and basically did this completely wrong. So it's good to kind of show what what's wrong about this. Well, it sticks fine. It's kind of a clean roto. So what's wrong about this method of kind of rotoscoping? We've got all these different elements, but it's not an efficient workflow for rotoscoping. So if we click on our Daniel character here, the way you should rotoscope is to create simplest forms as possible. So we've already got some quite natural, simple forms in here. But what we want to do is we want to separate out the head, we want to separate out the ears, we want to separate out the arms, we want to separate out the torso into separate roto nodes. And all of that can be within one roto node. We just add more layers into our scene, and we start naming things slightly differently. So all of our newer stuff, we're doing this in a much more organized way. Because it sounds like more work having to create more shapes, but if you think about it, you're doing like an oval shape for the head. You're kind of animating and moving that. If we just kind of go to our rotoscoping here, we need to animate and move that like over however many frames, and then we do the same for kind of spheres, or kind of ellipses for the ears. Same for kind of like, again, general shapes for the kind of torso, and then same again for the arms. We're creating kind of like ellipses and sausage shapes kind of forms to kind of follow our shape. And that means that we can kind of run through one pass of one element really quickly, go through it again, and we just have to be a lot less careful. It's a lot more work to actually go and move all of these small, minute little points around. And we're only kind of starting off with like rotos with four to six kind of Beziers in, rather than a rotor like this, which has got 40 Beziers or something like that, and we're having to manually animate all of those in one go. It's much more efficient to kind of take it in stages and do the head, the ears, the arms, all of that separately, basically. So again, this was done for all the elements we needed to do to cover our scene, which gives us this. So we had to also do some elements of the roofing here, because if we look on our feed, let's just turn off our motion blur for speed, because that's always the one that's going to slow us down. We've kind of got some elements where we need to kind of cut out on the tops here. So that will give us a roto view like this. The way that you plug that in is quite simple. You can have all of your different roto nodes. If we create a new merge node, we can kind of like, with the A channels, we can kind of start to add in, and the B, we put both of them in, sorry, and then once we add both of our inputs into two roto nodes, we automatically get another little line that comes out, and that allows us to kind of keep adding more and more feeds into our merge node. And let's try and explain this on the model here, on this kind of scene here. And then what we're doing if we double click this is that in our mask, it's RGBA alpha. So it's going to kind of read the alpha through our kind of pipe here. And then we're multiplying that on as we would normally. And we don't have to multiply. We could grade. So if we put a grade node in here, and we did the same thing, we piped in the mask to that stencil. Let's just disable this for now. We can do the same thing. We can grade our shadow as we want. And that means we can change the color. We can try and match this guy. So we want to make this more blue. Which is not making it more blue. It is if you change the grade here. So if we click on, we can change the color of any of these wheels. So we can kind of create whatever we feel is close. It's not that successful, this one. If we press Alt and then click on the little number next to this, it will kind of reset the it'll reset our whatever we've adjusted back to default settings. So it's quite useful to kind of get used to that. So this gives us a huge amount, much more control of kind of getting our shadows looking good than if we then bake that in, because it'd be really difficult to kind of grade that shadow to be a specific color if we baked it in. And the only reason why we've got this stencil node here, which is kind of complicating visually our setup, is because the stencil node is essentially taking this mask, but it's also combining it with our main masks here. So that means we can, this roto pipe system that we developed can kind of cut our main render, but it can also kind of cut into our any other elements we add. And this is kind of a little bit more complicated a setup, and it really just needs a slightly more of an understanding of Nuke to kind of understand the different parameters of the merge node, basically. Because the stencil is it's literally stenciling these two together. So if we simplify this for the sake of this tutorial, because if we don't want to cut out our woman and our van and our car, the reason why we've done that, obviously, is because in our comp we have lots of things that pass in front of this scene, like this car, right? So if we didn't use this stencil node, and we just masked straight into our shuffle node, then we're not masking the shadow. You know, it's going to be on top. The reason why we've put that there is because we can not only mask this grade or tell this grade to use from our matte shadow material, we're saying also take into account all these other roto nodes we've made. So let's have a look at this again slightly. So we have a woman, we have our van rotoed out, which was very rough. It didn't have to be accurate, it's just because it's such a fast moving object. We have a woman that kind of appears here. Again, she was very rough. We have different elements of our bike. If we just click on each one, click on this, we can see them all. These are just different bits that we're kind of rotoing out in different areas in the same method. So we're happy with that. We have to make sure that we kind of add our real smart motion blur also to our V-Ray matte shadow material, because that's in a separate location. It's not going to be affected by the real smart motion blur we have here, obviously. And again, we want to match this bike with our trailer here. So now that's kind of sitting in quite nicely. You can see that because we kind of looked at our roto nodes and we clicked on them, you can see this kind of red line in the viewport, and we can't seem to kind of get rid of it. Pressing O turns off overlay mode, and it means that you can just get rid of any roto or kind of graphical elements that you use to build things in your scene separately. So this kind of, it's in viewer mode and kind of construction mode is this O O button. And then to finish it off, we've got our dirt, which again, we rendered this out in After Effects and we forgot to change the frame range within our composition. So it started from 0, even though our comp doesn't start from 0. So we can render it out again, or we can just simply put a time offset node in there. And that's just going to match our time here. And what we actually did for this, because we were rendering this out back out in After Effects anyway, we also added the motion blur in After Effects, so we didn't have to have another real smart motion blur node in here, adding kind of complexity to our scene. So here we've got our dirt mode on top. So that's pretty simple how we kind of added our trailer here, once you understand just that we have to do the shadows separately. All this is relatively straightforward. It's nothing different to what we've done earlier this afternoon. The only difference here is that we're kind of grading our shadow separately, and we're adding in our dirt separately. You can see that this is above our merge over node. So this is our node that's bringing in our render. And then if we just get rid of this grade, and then essentially we're using this twice, we're kind of doubling up this multiply effect, to get a darker shadow, because we didn't feel like it kind of worked with just one. So we could have one, but we've got two here. They're doing the exact same thing. But the important thing is that they're above the render, and that's because they're under the render on top of the footage. So footage at the bottom, shadow next, and then the render. That's kind of how it works. And the reason for that is because it's not just the actual shadow, it's the kind of context for the entire scene that it's creating. So we definitely don't want to grade all of this stuff, because that's going to be grading on top of our render. You know, it has to go underneath the render on top of the footage, so that we're kind of actually like grading our footage there, and then we're also then putting our render on top. See? Were there any questions about this kind of particular setup by anyone in the room or online? Okay, right. So hopefully everyone's with me, and they're kind of excited about trying out Nuke out for themselves and their projects. I'm going to look a little bit in detail at the inside of the fish scene that we were quite happy with, but never got used. And this whole kind of section got cut from the film by Film 4, and they never quite understood it, and it just didn't make the final cut, which is a shame. We keep talking about making a kind of director's cut version, but just haven't quite got around to it yet. So what we've got here, if we look at this scene, is a fully rendered shot with green screen footage of our characters within the shot, but they're not moving. That's the thing. These characters were filmed on I think a Sony camera. I'm not entirely sure, but they were filmed in a green screen studio and from a static location, because we knew exactly what we wanted to do for this shot. We knew that they were going to be, we were going to have a digital camera movement, and we were going to put them on cards. So again, in Max, I haven't got the Max file with me. This file would never work in a tutorial. It's probably the heaviest file I've ever built. All of this kind of caging and skin was all made in ZBrush and brought in. It's a very, very heavy file. And then a lot of this architectural stuff was actually quite heavy as well. So there's nothing too special about how any of this was textured, apart from the ZBrush bones and skin, which were more evident in some of the earlier versions, which we don't have here, which were a bit more kind of gory and fish-like. This was kind of a secondary version. But essentially, what we needed to do here was obviously build our scene, do our camera move, get all happy with that, and then we had our cards in position. And in Max, what we did was we, on standard materials, we just had we keylighted our characters in a very rough way. We saved out a black and white mask of that key light, so we could use that as a opacity map, and then we essentially have that available in our viewport within Mac, so we can previs and see what's going on very, very quickly. I'll try and illustrate that in one of the making of videos. So if we can kind of, what I quite like to do is have a few of these doing different things. So we might have one which is a bit more intense, doing a kind of sharp highlight. We might pick another one, and again, what we'll do is we'll add a dot there and just attach it there, so that's feeding into our kind of tree. And we'll increase the intensity, we'll increase the diffuse, we'll kind of like, you can increase the foreground and background blurs. We might want to create one that kind of covers more of his, this either does the hot spots of the effect, you can kind of blend it more across the whole shape. Saturation values, it's also quite nice to play with. Yeah, all sorts of different parameters you can kind of mess around with. You can kind of generate the wrap only, which is quite interesting, which you can then, I guess, use to screen on top or use in a different blending mode on top of your other footages, but you'll have to kind of pipe this into your feed in a slightly different way. Disabling the luminance-based wrap won't read the kind of the pixels around the outside. It will just give a general overall effect, which you might want. Because you might want to have an overall glow around him, which isn't linked to the kind of pixels around the outside edge. And then enable glow does what it says on the tin. It kind of adds an outside glow to the kind of edge of your light wrap. So it's not, the effect isn't limited to inside the kind of the area here. So I quite like a subtle outer glow, just to again feather the transition between your footage and your background. And all of this adds to just the realism of your scene. Something that might obviously be needed, all of a sudden gives it a lot more believable comp. So if we disable those and plug back in the ones that I originally had, which are animated, we've gone for a slightly more subtle effect, I guess, with my one. But we have, this is animated to kind of be more intense in certain areas across the timeline. That's why they've got the little A next to it here. So then, once we've done all that, we're essentially down to our grade, and we're writing out our sequences at the bottom. And again, for writing out sequences with any comp within Nuke, let's just create a new folder in here. CG School Export Test. Type the name again, CG School Export Test. Dot hash 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 dot exr. Save. And then we're basically ready to render this out, and we can pick our frame ranges. But what's also good is that we can render in the background and then set how much of our system memory and thread limit to actually use. So it's not like rendering in After Effects when you have to wait for it for ages. It's more like the new Photoshop where it kind of just does it in the background. So we can say, okay, take 6 of these and 8 of these and press OK. And what that's now done is it's created a kind of dummy file of our comp, and it saved it somewhere else. God knows where it saves it. I think it saves it as the temp file. And then you can still work on your scene, right? If you just press render without rendering in background mode, you'd see this computing, you'd see lines glowing, you'd see something happening, right? And you'd know that you won't really want to mess with anything because it's going to change how it's exporting. Whereas rendering in the background, you can still edit and work on this file, work on the different nodes, and you don't have to worry about the kind of this not working or this not rendering out. So you can see here, it's taking 2 hours for some reason to export this out. Now, this will hopefully go down, but some of these scenes were quite heavy, and there was quite a lot of data that we're kind of pumping through it. Now, if we're in a rush, when we created this, we weren't really in a rush, so that was fine. We can let that go while we do something else. Nuke doesn't take up a load of memory. We've got a few files open. It's not using much of our CPU. This is a kind of raw render from a recent project that we've done, and this is kind of like a mid-stage, I guess, in the process. And how we've started using Nuke within projects, a standard kind of project would be kind of like 5 to 12 images for an architect, and in this particular case, leading onto an animation or a film. And for these kind of things, especially working with certain architects, it's going to be really tricky to keep feeding the images to the architects and the developers with good information, updates all the time. Sometimes you kind of built in fixed kind of like issues to the architects, but sometimes it's much more of a kind of process, especially with a project like this where the design wasn't necessarily fully realized before issuing the kind of information to us. So it was a bit of a designing process and a bit of a marketing. It was somewhere between marketing, images, and a designing process. They were used for marketing purposes, but we weren't issued with kind of final information. So there was lots of changes to this project, right? Lots of changes, lots of issues of renders. And what we've started doing, and we're going to use for all of our workflows now, is rendering out 2K images of our scenes. And Nuke can work with 2K very easily. It's going to struggle to go to 6K unless you've got a really fast network and a really fast graphics card. But what we're using it for isn't really for final production. It's for all the kind of niggly stages in between. And so basically, if we have our read nodes here, what we'll do is we'll have all of these read nodes stored in a current folder for the render of this project. So what we'll do is we'll render out the image. We'll save this within a dated folder, or the current folder rather. And then what we've started to do is set up this as almost like a batch command, but using Max and Nuke, where we have and we've kind of gone to like extreme referencing, where we have all of the model files referenced into a cam lighting file, and in that cam lighting file you've just got your lighting and your cameras as you would normally, but then that file is then referenced into a render send file, right? So the render send file has got nothing in it apart from an area to send your render, and what that means is you can send that to Backburner or wherever, whatever system you're using. And then whenever you update the camera, the lighting, any of the models, you can just press restart on that restart on that job in Backburner, and it's going to update everything for you, and it's going to render everything out in the same current folder, and all these nodes are going to update automatically. So what that does is gives us this mega fast workflow of essentially rendering out a set of images, setting up a comp like this. Now we've got the comp set up, we don't have to do that again. And then basically, all the models are worked on by several different artists throughout the day. The lighting is slightly changed. And then essentially all we have to do is select our folder within Backburner, we press restart, and it's going to essentially take all of that new data, render it again, update these files, and then everything we do here, every adjustment we make is automatically updated. So that gives us a huge speed advantage when it comes to changes, where we overnight or over lunchtime will have an updated set of renders that we can simply press export, and that is rendering out a JPEG, which is linked to an InDesign document, so that basically overnight we can kind of like press restart on all of our jobs, right? And then it automatically updates everything, and we automatically have an updated InDesign document which we have to PDF out and we send to the architects. It's completely streamlined our workflow for image sets. So we'll have a folder like this, a kind of system like this set up for every single camera, and then all we have to do is go into the Nuke files and render out and press write and render that back out. And you can just see the power of that. So it's kind of using a tool traditionally used for VFX and compositing for kind of like shots that we've just been doing, kind of CG within footage. I mean, this is not far off. It's just a still version. We've still got an image of our. This is the rendered version of the building, but this is a kind of image of the tower next door. So this is a photograph which is replaced in the same way as you would normally. We've got our sky that's rendered through our render here. We've even got our people that we've done in Photoshop and brought them in as a PNG here. So we're kind of testing that. We can kind of do everything in here. So again, we're just kind of doing a lot of stuff we do in Photoshop, but we're doing it in Nuke in a kind of way that we can see everything, which is quite nice. And then again, the glows and the grading and everything, it's all 32-bit and it all works fantastically. And when you get into Roto, you can kind of, you can do lots of different custom Roto masks. You can use Roto Paint. So it's exactly like painting a mask in Photoshop. When you get into it, you'll find that you can do everything you can do in Photoshop and more, and it's keeping that a 32-bit data set. The disadvantage of this workflow is that we thought we could just literally pump in our 6Ks and export, and it didn't quite work out because our network's not fast enough, basically. If you've got a very fast network, that system will work fine. What we've also started to play around with is essentially instancing all of these nodes to a separate 6K comp, labeling this 2K, labeling another one 6K, and then whatever we change within our 2K comp automatically changes in our 6K comp, and then all we have to do is export. We haven't got that workflow down yet, so I'm not going to go into that because it's not ready. But it's something we're playing around with to really try and streamline the development process of images. Because it's really annoying when you're kind of creating a comp in Photoshop to do an issue for an architect, and you've set up all your masks and everything, and it's really annoying to go back and change all of that, redo all your masks and that kind of thing. Whereas here, even if you change your camera, all your masks are going to stay exactly the same. You know, that green mask you've got here, you know, that's going to update. It's going to move with your new render set. These are all postage stamps. It's linking to the main read nodes. It's an incredibly powerful workflow that more and more people should adopt, in my opinion. And then essentially what we then did is that we used this to develop the 2Ks. Once we got complete sign-off of everything, so people, materials, textures, lighting, then we just render out our 6Ks. We faffed around with this for a little while to try and get it to work, and then we hadn't quite figured out that workflow with our current server, so we replicated what we had set here in Photoshop, but then you only have to do that once.